Good morning, ladies and gentlemen. This is Dave with another episode of Dave Does Math at Home. Today we are talking about section 5.4, the unit circle. Quick refresher on some stuff that we did in section 5.3. 5.3 we looked at what happens if you take angles and you put them in strange places. Or rather, we looked at what happened when you tried to make triangles out of angles that had more than 90 degrees. So to do this we use something called reference angles. So for example, if we wanted to talk about a 135 degree angle, that would put us here in quadrant 2. This is 135 degrees, which is also known as 5 pi over 4. No, 3 pi over 4. Yeah. So when we put our angle in quadrant 2 over here, we can make a triangle out of it, and if we set this length to 1, we were able to find the coordinates of this point at negative root 2 over 2 for the x value and root 2 over 2 for the y value. Because it's essentially the same as a 45 degree angle. It has a 45 degree reference angle if we make this triangle. If we make this triangle, we have a 45 degree angle here. This 45 degrees is the angle that actually goes inside the triangle. So this is 135 degrees on the coordinate axes, has a reference angle of 45 degrees, because if you make a triangle out of it, you still get a 45 degree right triangle. And then we looked at some other things. We talked about angles in the third quadrant having negative x and y values, and that means that they have negative sine and cosine values. In the fourth quadrant we got positive x values, negative y values. We did all that. That was section 5.3. In section 5.4 we're going to try to do all of that at once. So we're kind of just going to see what happens if we put all of the angles we know on the same set of axes. So I have 135 here. If I'm going to make a 45 degree angle, I'm going to make a 30 degree angle, and I'm going to make a 60 degree angle, all in quadrant 1. If I do this in radians, this is pi over 6. In radians, this is pi over 4. And in radians, this one is pi over 3. And I know the coordinates of all three of these points because these are very standard issue angles. Assuming that these distances are all 1, then the coordinates of this point are root 3 over 2, comma 1/2, root 2 over 2, root 2 over 2, and 1/2 root 3 over 2. These are my coordinates. In the second quadrant, I already have 135 degrees. I need this thing, which will give me a 60 degree reference angle in here. So the way I get the 60 degree reference angle is probably with a 120. Or sorry, I get the 60 degree reference angle with a 120 degree angle. And this is 2 pi over 3. And then I'll need a 30 degree reference angle as well. And I can get that. If I want this to be 30 degrees, this has to be 150 degrees, which is 5 pi over 6. So this is going to be the small x value, large y value. This is where they have the same magnitude. This one is going to be the small y value, big x value, and in quadrant 2 all of the x's are negative, all of the y's are positive. So these are my three reference angles in the second quadrant. I'm going to put 3 into the third quadrant as well. have 45 coming right down in the middle. We want the 30-degree reference angle coming out here, and we want the 60-degree reference angle coming out down there. So to get this 30-degree reference angle, I need to use 210 degrees. So 30 degrees past 180. And this will be the same as 7 pi over 6. To get the 45-degree reference angle, I should use 225. And that'll be 5 pi over 4. And to get the 60-degree reference angle, I need to use 60 degrees past 180, so this one should be 240. And that'll give me 4 pi over 3. So the coordinates of these points should end up being big negative x, small negative y, medium negative on both x and y for the 45-degree reference angle, and this one has the big y value, the small x value. There's those three. We're almost done. We need to put 3 angles into the 4th quadrant. So there's our 45. I feel like I'm just getting bigger and bigger lines here. Let me make that a little shorter. There you go. There's your 45-degree angle, or 45-degree reference angle. Here's a 60-degree reference angle. And here's our 30-degree reference angle. So this one needs to be 30 less than 360. So this will be 330 degrees, which is 11 pi over 6. This one is 45 shy of a full circle, so 315 is 7 pi over 4. This one is 60 degrees short of a full circle, so that'll be 300 degrees, which is 5 pi over 3. And the coordinates here are going to end up being big Y, little x, y is negative. Here they're the same, root 2 over 2, root 2 over 2. And y is negative, x is positive. And here I have big x, little y, y is negative. So these are all 12 of the important angles as they appear in each quadrant. This is your 30, your 45, and your 60-degree reference angle in each quadrant. It gives us 12 total angles. And we have the coordinates of each. And the beautiful thing about this is, because all of these sort of radial distances are equal to 1, it means that if I take any one of these things and try to make a triangle, I'll have a hypotenuse of 1, and the x and y value will be the length of the opposite side, the length of the adjacent side, which means that these x and y values correspond directly to sine and cosine values. All of these x values are cosines, all of these y values are sines. This is only true for these because they all have a distance of 1. On the homework, you're going to see some problems that will give you sort of bigger triangles, triangles with longer hypotenuses that are still on the coordinate axes. It's a very common mistake I see students make where once they see coordinate axes, they just immediately jump to x is sine, y is cosine. And that's not true. X is cosine and y is sine on this diagram because all of these distances are 1. If you extend these out past a distance of 1, this is no longer true. For those bigger ones, you still have to look at the sides of a triangle and talk about adjacent over hypotenuse. If the hypotenuse is 1, then it's easy. So, the fancy mathematical word for the collection of points that all have the same distance from a center, which is what's happening here. This is the center point. The origin is the center. All of these points are distance 1 from the center by design. We did that very intentionally. And the fancy mathematical word for this collection of points that are all equidistant from a center point is a circle. Which is why this diagram is called the unit circle. That one's a little short. There we go. This diagram is called the unit circle because it represents the coordinates of all of these points. I mean, obviously not all of them. Like, I don't know what the coordinates of this point are. That's fine. I probably don't care. I could find it if I really, really wanted to. Not super interested. These are the important ones. But something is sort of missing. We started talking about angles in these other quadrants because you can't make a right triangle that has one of these angles in it. But you can put one of these angles on a coordinate axis and then make a right triangle out of that angle. And the angle that actually goes in it is called the reference angle, and that's fine. So we're already kind of stretching this idea of 240 degrees as a triangle making angle. That much of a stretch is okay. We're going to stretch things a little bit further so that we can completely fill in the missing parts of this circle. You can't put a 240 degree angle in a triangle, but you can make a triangle out of it on the coordinate grid. You still get a triangle as a 60 degree reference angle all as well. What if we look at 90 degrees though? You can't make a triangle at all out of that. It's not just that you can't put a 90 degree angle or a second 90 degree angle into a right triangle. It's that there's no triangle at all. All of these angles that are currently on here make triangles. We can actually look at the triangle having 3 sides. You can't do that with 90 degrees, but we still know the coordinates of this point. This is a 90 degree angle. In radians, that's pi over 2. And the coordinates of this point are 0, 1. We can do that. That checks out. And because we have this relationship established so thoroughly, we can apply that to this as well. You can't make a right triangle with a 90 degree angle in it, but you can tell me that the sine of 90 degrees is 1. So that works. Mathematics might not make a ton of sense, but the mathematics is at least very consistent and reliable. We can put a point right here. This would be 180 degrees, which is known as pi radians. And the coordinates here are -1, 0. We can put a point down here at the very bottom. This is 270 degrees, which is also known as 3 pi over 2. And the coordinates here are 0, -1. And we can put a point right here with the coordinates 1, 0. This point usually gets labeled with 2 different angles because on the one side, this is where you start. This is 0 degrees, which is also 0 radians. Or you can think of this as 360 degrees, which is 2 pi radians. Both of those measurements will put you in the same place because they are coterminal. So this is the entire unit circle. I think this video is only going to be, or this lesson, the 5.4 lesson, is only going to be this one video. Just because once you already have trig functions of any angle, getting from there to the unit circle is a pretty small step. We just took it in about 15 minutes. While I am ending this video, I do want to encourage you to explore some of the patterns here. There's lots and lots of patterns in sort of everywhere. If you look at these numbers, 3, 2, 1, 0, that looks temptingly like a pattern. Maybe you could explore that, see if that keeps going. You can look at some of these angles. All of the 30 degree reference angles are pi over 6s. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. You can see if that's a relationship that holds. You could also explore where the missing pi over 6s went. If you're looking at pi over 6s, we have 1, 5, 7, and 11 of them. Where did 3 or 4 or 6 of them go. So, there is an incredible wealth of information here at your disposal. Tons of patterns that you could explore, find, look at, examine. I think you should do that. I'm not going to do it for you, but there's homework to encourage you to try. That's it for me. We'll see you next time.